Hello, my name is Brandon Vano, and I'm going into automotive engineering, so my project is going to revolve around cars. The project is about friction, more specifically, the coefficient of static friction. The focus is to show that neither weight nor size changes the coefficient of static friction. The only thing that does matter are the two surfaces that are pressed together. The layout is about a car on a surface that is gradually lifted perpendicular to the car until it slides. I will be using two cars of different size, weight, and wheel material. This project will display that neither the size nor the weight matter, but the material of the wheels sliding against the surface. The two cars that I'm going to be using during this project are a smaller toy car with a size 1/64th scale that of a real car. This car has a smaller wheelbase, which is the distance between the front and the back wheels, and a smaller track, which is the distance between the two front wheels. But we're going to focus on the fact that the wheels are made out of smooth, hard plastic. The larger car is 1/24th scale, the size of a real car. The car is not only larger, but heavier as well. Again, we will be focusing on the fact that the model toy has a rubber wheel compound comparative to the hard plastic wheels of the smaller car. The surface that we are using is my Surface Pro 3. The back of the computer is made out of a smooth magnesium alloy designed by Microsoft. The cars are going to be lined up at the slit of the top of the kickstand and slowly and carefully lifted with the help of an old phone case for extra stability. This is done until each of the cars slide. This experiment will be done 3 times each for accuracy. Each angle of the experiments will be measured to 1 decimal point with the help of a protractor. The average angle will then be used during the calculations. The step I took towards proving this through numbers was that I separated both the smaller and the larger cars and drew their individual free body diagrams. Next, I figured out the moment around wheel B, which is the higher wheel, to find the normal force acting upon wheel A. Then I added the sum of the forces in the y direction to equal 0 to find the normal force at wheel B. Lastly, I summed the forces in the x direction to 0 to find the coefficient of static friction. As expected, the smaller car has a smaller coefficient of static friction. The main cause of this was that the wheels on the smaller car are made from a smooth, hard plastic, while the compound of the wheels on that of the larger car are made from a hard rubber. This shows not only through the angle that each of them slid, but also through the calculations that we did. This proves that neither the size nor the weight have anything to do with the coefficient of static friction. The true factor lies within the compound of the two materials in contact with each other.